Okay, first derivative of a function. First derivative of a function fx by using first principle. Okay, we are going to find the tangent. This tangent AT is 8 minus 4 over 3 minus 2. So the tangent is equal to 4. If, okay, this is a curve, right? If I change a point, become 3, 9, how is it? Okay, let's see. Move. Okay. B to C. This one, the C, it will plus delta x plus delta y. It means it plus a small change. From B, this is x and y. It plus a very small change. Become x plus delta x, y plus very small change plus delta y. So this is very small, meaning 0.0001 here. Alright, so the gradient will be this over this, right? Okay, let's see. Now, after the y2 minus y1 over x2 minus x1, you get delta y over delta x. Delta y over delta x. That means the gradient is delta y over delta x. So the gradient at curve at B is a gradient of tangent BT. And this value will be when delta x approaching 0, meaning the x is very small, approaching 0, and delta y, delta x. Therefore, okay, never mind, just remember this thing. dy dx is equals to limit delta x to 0, delta x approach 0, delta y, delta x. Where delta y, delta x actually is function f x plus delta x minus fx over delta x. Remember this enough. And delta y actually, whenever there's function, you see here, this x square, right? So the x square, I substitute, when there's x here, I plus the delta x here. Okay? I plus the delta x here. And then minus you follow this one, minus the fx. So this is x squared. So x squared will be x plus delta x whole thing square. Substitute value inside here. This is x squared. So x squared minus x squared. Where the first one is the x plus delta x inside here. X plus delta x. Second one is x. And then expand it. X squared plus 2x delta x. Okay, 2x delta x plus delta x squared. From here to here, actually use the what we call this one, like a plus b squared equals to a squared plus 2ab plus b squared. That one is x plus delta x squared. So a squared, the first one, plus 2 multiply ab. So 2 multiply x multiply delta x plus behind b squared. So delta x whole thing squared. So you get this one. Okay, minus x squared. This one you copy down. Then you simplify. This one x squared minus x squared no more. So you just substitute this one. Copy down. 2x delta x plus delta x squared. And then the delta x go there. Then divide lah. This one divide delta x, delta y divide delta x. This one divide delta x and divide delta x. Cancel 2x. Cancel delta x. So this is the answer. Delta y delta x equals to 2x plus delta x. And from here, dy dx equals to limit delta x approach 0, delta y delta x, and delta y delta x. This one you substitute here. Okay, now you just do the limit like just now. When limit x delta x equals to 0 here. So when you want to start to do limit, you don't need to copy the limit anymore. You just copy this and substitute value inside. Then you will get 2x. And this is gradient of the tangent function. dy dx is equals to the gradient of the tangent function. Okay, let's see example 3. Find the dy dx. So I give you another example. The textbook example is 3x. I use 2x. Okay, let's see this one first. Later we do 2x. Okay, y equals to 3x. So we start with delta y equals to function. Okay, this one you copy down. First, we use the f delta x plus delta x minus fx. So now we start it. We are given function is 3x, so 3x, and inside the bracket is x plus delta x minus x. Then simplify 3x plus 3 delta x minus 3x. 3x minus 3x no more, so 3 delta x. This one delta x go there, divide, you get 3. And divide the x to the limit delta x approaching 0 divide delta y delta x. Delta y delta x to 3, substitute here. No more x, so no need substitute x. So answer is limit is equals to 0. Divide dx equals to 3. So answer equals to 3, not 0. Divide dx equals to 3. Okay, start with this one. Wait. I put example first. Then, okay, let's see. I do 2x. So start. We are using delta y equals to delta y equals to what is the first step just now? F x plus delta x minus fx. First step. Okay, now what is the function f? Sorry, this is y equal. Okay, y means fx. Function f say 2x. 2x. So this one function also 2x. Okay, whenever you apply function, whatever the bracket is substitute inside, right? So whatever in the bracket, you substitute inside. Now, so expand it. 2x plus 2 delta x minus 2x. 2x minus 2x no more, so 2 delta x. Now I want delta y over delta x over there, so you get 2. Then dy dx equals to limit delta x equals delta x approach 0, delta y delta x, and delta y delta x equals 2, so you limit delta x approaching 0, 2, and when you substitute 2, the x no more x here, so answer equals to 2. So dy dx equals to 2, and dy dx actually is gradient of the tangent function. It's very important because you need to understand what is dy dx. It's useful when you want to answer the question in application. Dy dx is gradient of the tangent function. Okay, so finish. This one very long method. This one we call method the first principle. By using first principle only, we use this one, and it's quite long, but never mind. Later we get shortcut to find the gradient of the tangent function. To find the gradient, you will find dy dx. Here we are using first principle. Okay, using first principle function. First principle method. Okay, now let's try again by using first principle method. Delta y equals to f x plus delta x minus fx. Okay, start with here. So f function is, now we can apply already. F function is 2x squared. So minus again f function 2x squared. So this one substitute inside x plus delta x. This one substitute inside x. So this one we want to expand now. See, this one I explained to you just now. Alright, we start now to expand. This one 2 is copy down. This one expand. First one, x squared plus 2x delta x, 2ab plus behind here delta x squared. Okay, minus 2x squared. Okay, now expand here 2 inside, expand up. So you get 2x squared plus 4x delta x plus 2 delta x squared minus 2x squared. 2x squared later you cancel with 2x squared, no more. Then you left here. So now your delta y over delta x equals to, this one over delta x go there, no more, so 4x. Delta x go there, you become 2 delta x. Okay, so this is delta y delta x. And now we want to find dy dx by using first principle. This one using first principle. Dy dx equals to limit delta x approach 0, delta y delta x. This is a method lah. Then now we substitute the delta y delta x here, 4x plus 2 delta x. When you substitute here, you don't need to write limit anymore. Okay, here 4x plus 2, 0. So answer equals to 4x. 4x is dy dx, is the gradient of the function 2x squared. Okay, this is almost the same example be in your textbook, but I use different example. I use 2x squared. Okay, now let's see number C. Okay, your example. Okay, again, delta y equals to fx plus delta x minus fx. Function f saying 2x cubed. Okay, minus function f saying 2x cubed. Whatever in the bracket, you substitute down inside. Whatever in the bracket, substitute inside. Okay, now this one power 3, how to expand? Power 3, you can expand like 1 power and power 2. This one quite long. Okay, this one 2x cubed. Okay, we'll expand inside first. Or we expand later. Expand later lah, the 2 here. Okay. Now I copy down this one first. Oh, this one very long. Okay. X squared plus 2x delta x plus delta x squared minus 2x cubed later. Okay, this one copy now. Now 2. Okay, this one first to this one, second to here. Okay, so now first to first, first to second, first to third, second to first, second to second, second to third. Quite long. Then I will do. First principle memang so long one. So first to first, x cubed. First to second plus 2x squared delta x. First to third plus x delta x whole thing squared. Second to first plus delta x times x squared. Second to first, second to second plus 2x delta x whole thing squared. Third to third, second to third plus delta x power 3. Okay, minus 2x cubed. Okay, now the 2 you may go inside. Okay, the 2 may go inside. Inside can simplify or not? Cannot. So just continue do lah. Alright. 2x power 3 plus 4x squared delta x plus 2x delta x squared. Okay. Oh, here is x delta x squared. Here is 2x delta x squared. Plus 2 4x delta x squared. Later these two can combine, become 6x. Okay, plus. Okay, I miss out here. This one, first, second, third, fourth, I miss out here. 2 delta x squared. 2 delta x times x squared. So same with here later. These two can combine. X squared and delta x squared and delta x can combine. x squared and delta x squared and delta x can combine. Later these two can combine. Okay. And I copy first, plus 2 delta x power 3 minus 2x power 3. We have not enough space. Go up here. Okay. So delta y equals to 2x power 3. Okay. This one, x squared delta x squared delta x. Okay, so plus 6 x squared delta x. Okay, then another one will be 2x delta x squared, 4x delta x squared, these two. So it will be plus 6x delta x squared. And then minus 2 delta x power 3 minus 2 power 3. So minus 2 power 3, 2x power 3, later cancel lah. Now delta y over delta x equals to, okay, this one and this one cancel no more. Okay, delta x and delta y over, so 6x squared plus 6x delta x, because 1 only, minus 2 delta x squared. Okay, this one is delta y, delta x. There's 3 terms, 3 terms. This one is square now, 3 terms. Okay, now after the delta y, delta x, sorry, a little bit messy, not enough space. Yeah. Okay, I continue here better. Continue here. dy dx equals to limit x approach 0, delta y, delta x. 6x squared plus 6x delta x minus 2 delta x squared equals to, now sorry, here is delta x. So I substitute delta x 0, delta x 0. So equals to 6x squared. Okay, delta x is substitute 0, no more. This one multiply 0, no more. So dy dx equals to 6x squared. dy dx equals to 6x squared. Done. Okay, so this one we're using first principle, you find the answer. Alright, so I want to touch a little bit. If you don't want to use first principle, I use a first derivative. Okay, we're going to learn this later. First derivative, given a x power n. So this one, no need to first principle. We find dy dx straight away. A times n, x power n minus 1 dy dx. Okay, for example, just now, y equals to 2x. So dy dx equals to, this one, x, no power means power 1. 1, 2, 2, x. 1 minus 1, no more, 0. If x power 0 equals to 1, so dy dx equals to 2. Okay, so the first one, when y equals to 2x, your answer dy dx is 2. The second one, what's the second one? Okay, 2x squared. 2x squared and 2x cubed. Okay. When y equals to 2x squared, dy dx equals to a times n. 2, 2, 4. X. 2 minus 1 is 1. So 4x. Answer 4x on this one. Okay, answer 4x here. 2, 2, 4, 4x. Okay, the last one. 2 power 2 y equals to 2x power 3. So dy dx equals to 3 times 2, 6. X, 3 minus 1, 2. So we use this shortcut method. This one later we will going to touch this one. First derivative. You found this answer, and the answer equals to, if you are using by first principle, but very long. If the question never requests you by using first principle, So just to find dy dx, you can use the shortcut method. But if the question saying find the dy dx by using the first principles, if the question got mentioned by using first principle, you must start with this. Delta y equals to fx plus delta x minus fx, and then you find the delta y delta x. After that, you find dy dx equals to the limit delta x approach to 0, delta y delta x, you get the answer. Okay, the first principle done. The simple one, you see this simple one. Okay, remember this one. Start, and then delta y delta x, to substitute here, because dy dx equals to limit delta x approaching 0, delta y delta x. Then this is the answer. And then the answer actually is a gradient of the tangent function.